quick video on how to find the domain of a function. Now we've got to be really careful. Sometimes I could ask you to find the domain of a polynomial function, a quadratic like this parabola here, a cubic like this graph over here, linear, a straight line. And you'll find that if it is a polynomial function, the domain, because when you get to the end of these graphs are just arrows, and if you remember right, these arrows represent two motions. One, in this case, will be going to the left and the other one straight up. Now, of course, the only one we're interested in for domains is this going to the left portion. And this arrow over here really represents going to the right. So the domain of this function, being a quadratic, is all real numbers. And the same thing happens over here when we're dealing with the cubic graph. These arrows, one is pointing to the left if we're talking about just x values, and the other one is pointing to the right. So again, we have a domain of all real numbers. So if it's a polynomial function, the domain is all real numbers. So the only way to get a domain other than polynomial function, all real numbers, is to create a rational function. So we have a variable in the denominator, like this one. Or we could have a square root function, like this one, and this would cause some problems. It's not all real numbers anymore. Or we could take both of them and put them together and have a square root and a rational expression at once. So when we're dealing with fractions and radicals, the two things that come into play is, for fractions at least, the denominator cannot equal 0. If you're having a fractional expression, the bottom cannot be equal to 0. So with fractions, we have to know that the denominator is not equal to 0. With radicals, you cannot take the square root of negative numbers. So the numbers underneath the square root have to be positive. All right. So those are the big two concepts of finding the domain of a function. If you have a polynomial function, all real numbers. If you have a fractional function, then you have to worry about the denominator and making sure that it's not equal to 0 for any values of x. That doesn't mean x equals 0 is part of that. Not always. And then if you have a square root, you have to worry about the inside, in this case 3 minus 2x, has to be positive. All right, so let's go through and find out what the denominator of f of x here is. So I don't care about the 2x minus 1. That's really not even part of my thinking when I'm looking for a domain. So I'm going to take the bottom, the denominator. So x squared minus 4x minus 12. And initially I'm going to set it equal to 0. Now I'm not really going to, well, I'm going to solve this, but my essence is, again, not equal to 0. But we're used to solving equations that have equal 0. So we're looking for factors of 12 that subtract up to 4, which would be 6 and 2. So we're going to factor this, and it quick factors because it has a lead coefficient of 1. And we know it's going to be x and x, and we know it's going to be 6 and 2. Well, it makes it a negative 6 and a positive 2. So that'll give us our negative 4x. So we're going to get these two solutions, one of them being positive 6 and the other one being negative 2. And because these are what force the denominator to equal 0, we're going to say that the domain, and I'm going to write it this way, where x's cannot equal these two numbers is what we're looking for. The domain of this function, domain of f of x, is where x is not equal to 6 and negative 2. Now, explicit notation to write the answer out so it includes all the possible answers except for 6 and negative 2 would be to write it in interval notation. Now, interval notation, you'd be coming from negative infinity, you would stop at negative 2, and to jump over it, you would just parentheses both sides. So you'd have, stops at negative 2 and starts at negative 2 and goes on. And then it'll stop again at 6, and then it'll take off from 6 and go off to infinity. I just find this notation to be long-winded. This gets across the same information that it can't be 6 and it can't be negative 2, but it can be all the other real numbers. And that's just the assumption. All right, so if we go to the radical expression, the radical function, and the key here is to keep the inside positive. So the inside here is 3x minus 2, or I keep saying that, 3 minus 2x. So I want to make sure that 3 minus 2x is a positive number. Well, to say that mathematically is to say that the number is greater or equal to 0. I'm not saying that x is greater than or equal to 0. I'm saying that this whole thing on the inside of the radical is positive, greater than or equal to 0. And then just solve this equation, or inequality. And you get negative 2x is greater than or equal to negative 3. And then divide both sides by negative 2, and you get x is, remember to flip the inequality because you divided by a negative, and you get x is less than or equal to 3 halves. Now this one I prefer writing it in interval notation. It's not that hard. So you have the domain of this function f. It's less than 3 halves, so it's going to go off to negative infinity, and it'll stop at 3 halves. And it's an equal to situation, so it's a bracket. So there's the domain of f of x. Now, if we mix and match them and put a radical and a fraction into the same expression, function, we get something that looks like this. And we have to do two pieces. The radical we have to make sure stays positive. And the denominator we have to make sure is not equal to 0. All right. So let's deal with the top part first. Let's do it in green. So we have x minus 3. And we want to make sure that it's positive, greater than or equal to 0. All right, and then solving it's easy. You get x is greater than or equal to 3, add 3 to both sides. And the domain of that piece, let's call it top. The domain of the top is going to be from 3 to infinity. All right, let's do the bottom in purple. Now the bottom, the denominator, we definitely do not want equal to 0. So we're going to solve this thing for 0 and then get rid of the answers that we get. So factors of 6 is subtract up to 5. Well, that would be 6 and 1. So we're going to factor it out. And we get x, 6, 1. The 6 is negative. The 1 is positive, so we get that negative 5. And we're going to get x is equal to 6 and x is equal to negative 1. Now, when I write the domain for just the denominator piece, so let's call this bottom, we're going to say that x definitely cannot equal 6 or negative 1, but it can equal any other real number going. Now, the trick here is it has to work for the whole thing. So whatever works for the top has to work for the bottom. Whatever works for the bottom has to work for the top. So we have this bottom saying that it can't be 6 or negative 1, and we have the top saying that it has to be bigger than 3. So we have to kind of push them together and see what works for both of them. So what's going to work for both of them, the domain of the whole thing, is going to start at 3. We can't get any smaller than 3. 2 is not going to work here in the green part, but it would work in the purple, but I need it to work for both of them. So it's going to start at 3. And it's going to work its way up, and negative 1 doesn't even come into play here because, well, it's less than 3. But that 6 is a problem. So when we get to 6, we're going to have to stop. And we're going to have to jump over it. And then we're going to start up again at 6 and go off to infinity. So this is a weird function where one domain and another coming together just creates this little jump. So we go 3 to infinity and we ignore 6 completely. So this would be the domain of this function, the square root of x minus 3 over x squared minus 5x minus 6. That's a tricky one. I hope this helped.